a data warehouse is a large collection of data. Okay, it's a repository that stores all the data that's available in a particular enterprise. Okay, and this enterprise is considered to be a huge enterprise. Okay, and it might have several different branches in different locations. That's one aspect. There are different branches, and in each branch or overall there might be different departments. There might be an accountancy department, there might be a marketing department, and so on. Okay, so there are different departments, there might be different branches, and there's a large amount of data that is segregated into different parts all over the enterprise. Now the data warehouse model tries to bring all this data from all these different places into one common repository. Now what is the need for this? The need is basically to enhance the data, the decision making. It's to help in decision support. Okay, so it's to help the top level managers of the enterprise to be able to look at all this data in one snapshot and bird's eye view kind of snapshot, and look at all this data and help them in making decisions about how to run their companies. Okay, so now the typical definition of a data warehouse involves these 4 different aspects. Okay, so a data warehouse is said to be subject oriented. Subject oriented means that the different parts of the data that is present in the data warehouse, they're all organized in terms of subjects, and subjects could be like this. You know, so this is an example. So you have let's say different stores, different locations of the branches. Okay, you have the different products that are sold in these different locations and the amount of sales, how much of these products are sold. Okay, so these are what is called as subjects here. Okay, and there are 2 kinds of subjects. One is called as the so basically, shall we start? Okay, data warehouse is a large collection of data. It's a huge repository of data of an entire enterprise. Okay, and the enterprise is considered to be a huge entity. Okay, so it might have many branches at different locations. It might have many different departments. There might be an accountancy department, a marketing department, and so on, each maintaining its own set of data. Now the purpose is to take all the data in all these different branches and in all these different departments and bring them together in one repository, call it as the data warehouse. Okay, so now what is the need for doing this? Okay, so the main purpose of this is to help in decision making. Okay, so this is called decision support, and the purpose is to help the top level managers of this enterprise in order to get a bird's eye view of all the data that's present in their company, and that helps them to make decisions about how to run the company better. Okay, so a data warehouse, the normal definition of a data warehouse involves these 4 different terms. Okay, the first here is called subject oriented. Okay, so a data warehouse is organized in a subject oriented fashion. Okay, so here is an example. You have different these are 3 different subjects here. Okay, in this very small data warehouse. This is just for illustration purpose. Okay, and here these 2 subjects are called as dimensions, and this 3rd subject here is called as a measure. So the measure has to be a numeric measure here, a numeric attribute, and you want to study basically how this measure is related, how it changes depending on the different dimensions. Okay, so how is the sales affected in the different stores? Which stores are giving you more sales? Okay, and which products are giving you more sales? Which products are giving you less sales? And things like that. Okay, so you want to study those kinds of relationships between the dimensions and between the measure. Okay, so that is what we mean by subject oriented. Okay, so then the second aspect of a data warehouse is that it's integrated. Integrated means from all the different departments, all the different locations, all the different branches where this enterprise is present, from all those locations, okay, and all the departments, the data is integrated into one place. And obviously this is a huge effort. Although we just say one term here, there's a lot of effort in order to do this, because at different places there might be different formats, the data might be unclean, okay, because it's manually entered into the database, and some of the values might be missing, okay, things like that. So first we need to do all the data pre-processing tasks here. We need to gather the data, we need to clean the data, we need to normalize the data and so on. And basically all that comes as the integration effort. The third aspect of a data warehouse is that it is time variant. Okay, so which means that normally in a regular database, you just maintain the data of a particular time period, let's say for the past 1 year. Okay, and you need the data only for, let's say, doing some accountants, for accountancy purpose or whatever. You want to keep a record of all the data, of all the transactions that are happening in, let's say, your store. Okay, so and beyond that, it's not of much use. Okay, so you don't really need data 10 years back. Okay, so you just need the current year's worth of data. Okay, but in a data warehouse, you have data of all the different time periods of all the previous years also. Okay, you don't lose any amount of data, because that data might be useful for finding patterns, and those patterns might be useful for decision making. So you don't want to lose any of the data. You keep all the data together. Okay, so it is time variant, okay, across different years. Okay, and the last aspect of a data warehouse here in the definition is that it is non-volatile, which means that the data warehouse is meant to be a non-volatile storage of all the data. Okay, it's not meant like a regular database. After 1 year, you delete all the past records. Data warehouse is not meant to be like that. It's meant to store all the records forever. Okay, so there's a huge investment in making a data warehouse. Okay, of the number of storage servers that you need to have, the number of computing servers that you need to have, because there is a lot of intensive computing that need to be done in order to apply different algorithms on this data in order to produce reports and results to the top level managers so that they can get a bird's eye view of the data. So if the data is gigabytes or terabytes big, then the amount of processing that needs to be done in order to get a snapshot of the data is actually a huge amount of work. Okay, so this is what a data warehouse is. Okay, and there are two different kinds of things that you can do on a data warehouse. One is called Olap, and the second is data mining. So Olap generally is an enhancement of what you can do in regular databases. In regular databases, you basically do only SQL. Okay, so you can do some kinds of aggregations and so on in SQL to get some kind of reports. But you want to do much more in a data warehouse. You want to get much more. You want to do all different kinds of aggregations, and you want to do multiple aggregations together on a variety, on a large amount of data. Okay, and to do it efficiently, the data in a data warehouse is structured very differently from how it would be structured in a database. Okay, in a database you just have normalized tables. Okay, in a data warehouse things could be structured in a very different fashion. Okay, so this is Olap, where you do an enhanced version of aggregation, different kinds of queries you have called Olap Queries. Okay, and the output of these Olap is a set of reports which will be a good kind of aggregations. For example, suppose here is your the data warehouse consists of these dimensions and these measures. Okay, so given a table like this, you can actually aggregate it based on store. Okay, so aggregate based on store, and you get this kind of table where for a product across all the stores, you have aggregating over the stores. So across all the stores for a given product, what is the total sales? Okay, or you can aggregate based on product and get this kind of table. Okay, so here you are aggregating for a given store across all the products. For all the products, what is the total amount of sales that is there? Or you can aggregate further, basically combine these two tables, and you get a view of this kind. Okay, so here you have aggregated based on product and store, and you got the total aggregate of what is the total amount of sales in the entire enterprise. Okay, so this is a small miniature version of what kinds of things you can do in a data warehouse. Okay, so these are the kinds of things you'll be learning in data warehousing.